All right, folks, welcome back. We're going to take a look at electrolytes now. First off, we wanted to understand what an electrolyte is. Okay, so we ask ourselves, what is an electrolyte? An electrolyte is a substance that has the ability to conduct electricity when it's in solution. Okay, and that means when it's been dissolved into water. Okay, so it can conduct electricity. Okay, so basically what has to happen in order for something to conduct electricity is we have to have a movement of electrons. Okay, we have to have some way for electrons to be able to move. So that provides us with the opportunity for electrons to move. Okay. So first off, it says that soluble ionic compounds are strong electrolytes. Okay, soluble ionic compounds are going to be strong electrolytes, okay? And what a strong electrolyte is it's going to be something that's going to 100% dissociate, okay? Kind of like we were talking about the strong acids and strong bases earlier, which 100% dissociate. Soluble ionic compounds, when they're mixed with water, are going to 100% dissociate, okay? Since we have lots and lots and lots of ions that are now mobile that allow for electric current to pass along it, we would say that that's going to be a strong electrolyte because there's a lot of spaces for that electrical current to bounce around on. Okay, so that gets us to this next part here, which, as you've probably guessed, strong acids and strong bases are also strong electrolytes for the same reason. Okay, it provides that motility for electrons to bounce where they need to go. Weak acids and weak bases are going to be our only weak electrolytes, okay? And remember, we talked about weak acids and weak bases on the previous video, and essentially what's going on there is that you've got some of those acids and bases which are going to separate or ionize, and others are going to stay together, all right? So most of them are going to stay put, whereas just a few are going to separate, so that's going to give you fewer opportunities for an electrical current to bounce around. All right, so let's erase this real quick. Fun with erasers. Okay, we're erased, and let's keep on moving. Okay, so now this gives us another idea here. It says that melted ionic compounds, okay, these are going to conduct electricity. Okay, a melted ionic compound will conduct electricity. The problem is that it's not a solution. Okay, in order for something to be considered an electrolyte, it has to be dissolved in water. Okay, it has to be a solution which conducts electricity. Okay, since a melted ionic compound is not a solution, since it's not a homogeneous mixture, we cannot say that it is an electrolyte. Okay. Lastly, we also know that metals will conduct electricity, but once again, we're not going to say that that's an electrolyte because it's not an ionic compound or an acid or a base that's been dissolved in water to make a solution. Okay, so what we want to do now is we want to take a look at some different situations that we have, and we want to see if those situations would be considered electrolytes or not. So let's take a look and see what we have. Okay, first off, I've got ammonium carbonate. Okay, ammonium carbonate is going to be written out like this. Okay, we've got NH4. Okay, carbonate is CO3. Remember, ammonium has a +1 charge and carbonate has a -2 charge. So that means that I need two of these ammoniums in order to cancel out the -2 charge that carbonate has. Okay, so the question now becomes, is ammonium carbonate an ionic compound, an acid, a base, or is it covalent? Okay, of course ammonium carbonate is an ionic compound. Question now, is it soluble? Okay, if it is soluble, then that means it's either got to obey like dissolves like, or it has to be an ionic compound dissolved in water, which means that we have to follow our solubility rules. Okay, well, I know based on our solubility rules that all ammonium substances are always soluble, and there's no exceptions to that rule. So is it soluble? Yes, it is soluble. Okay, so now if we were to scroll back up and look back at our notes from a moment ago, we know that if I have an ionic compound dissolved in water, we know that that is a strong electrolyte. Okay, let's look at copper 2 sulfide. Okay, copper 2 sulfide, I've got Cu. I know that that Roman numeral 2 means that it has a +2 charge, and sulfite is SO3. Okay, well, sulfite, of course, has a -2 charge. Copper has a +2 charge, so I just need 1 and 1. Okay, is this an ionic compound, an acid, a base, or is it covalent? Of course, copper 2 sulfite is ionic. Now the question becomes, is it soluble? Okay, I look at my solubility rules. I see that sulfate is soluble with some exceptions, but sulfite is not. Okay, sulfite falls into that very last category that says all other monatomic and polyatomic ions are insoluble except with if it's with a group 1 or an ammonium. Okay, well, this isn't a group 1 or an ammonium, so I know that this is insoluble. Okay, well, couldn't it be a strong or a weak electrolyte if it's insoluble? The answer is no. This is a non-electrolyte. Okay, it is a non-electrolyte because it doesn't even dissolve. Okay, it has to be a solution in order for it to be considered to be an electrolyte. Okay, let's do one more of these. Well, let's see what we got on this next page here. Yeah, let's take a look at calcium chloride. Why not? Okay, so calcium chloride, of course, is CaCl2. Here's a little reminder question. What would be the I value for this? Okay, I've got 1 calcium and 2 chloride, so isn't our I value going to be 3 for this? Okay, something we need to remember how to do. Okay, I know it's not asking us for it right now, but it is something we need to make sure that we know how to do. Okay, of course, calcium chloride is an ionic compound. Okay, I know that all chlorides, bromides, and iodides are soluble, except, and calcium is not one of my exceptions. So is it soluble? Yes, it is. Is it a strong, weak, or whatever electrolyte? Okay, this is going to be a strong electrolyte. Once again, anytime you have an ionic compound that's dissolved in water, okay, if it's ionic dissolved in water, it's always going to be a strong electrolyte. Okay, well, now you're probably asking yourselves, when are we going to see a weak electrolyte? Let's take a look at acetic acid down here. Okay, acetic acid is HC2H3O2. Okay, of course, acetic acid, obviously, it's going to be an acid. Okay, and is it soluble? Yes, all acids are going to be soluble. Okay, so we're going to say that yes, this is soluble. But now the question becomes, is acetic acid one of our strong acids or is it a weak acid? Okay, well, check this out. Okay, I remember from my last video that there are 7 strong acids. Okay, HCl, HBr, HI, HNO3, H2SO4, HClO3, and HClO4. Okay, well, acetic acid does not fall into that group. So therefore, it is a weak acid, thus making it a weak electrolyte. Awesome. Okay, let's do one more. Why not? Okay, what do you want to do? Methane or ammonia? Okay, we'll do ammonia. So here goes ammonia, which is NH3. Okay. Now, one thing you may not know at this level, in fact, you probably don't know this yet, is that ammonia is a base. Okay. So since this is a base, okay, we're going to say that yes, it is soluble. Okay. And so now the question becomes, is it a strong electrolyte, a weak electrolyte, whatever the case may be? Since it's a weak base, it's going to be a weak electrolyte. Okay, so that's going to wrap it up for electrolytes for right now. We're going to hit up some more stuff later. Thanks.